Coming up on This Week in Radio Tech, Intercom over IP. It's pretty amazing stuff. We're going to have a little history of Intercom and all of its uses and technologies, and then talk about Intercom over IP. Martin Dyster, the world's expert on Intercom over IP, is our guest. It's coming up next on TWiRT. This Week in Radio Tech is brought to you by Broadcasters General Store, with outstanding service, savings, and support. Online at bgs.cc. By Angry Audio. Audio problems disappear when you get angry at angryaudio.com. And by the CalRec Type R console system. Type R is a brand new, modular, expandable IP-based radio system from CalRec Audio. Hey, welcome into This Week in Radio Tech, the show where we talk about everything from the microphone to the light bulb at the top of the tower. And today we're going to talk about, well, we're going to end up talking about one of the things behind me right here. I just lit it up. This, wow, that's a lot of lights. We're going to talk about Intercom over IP because, we talk about everything and try to learn about everything that has to do with broadcast and media production. If you're new to the show, welcome in. We advertised this particular episode to a little bit different crowd of people that we usually do. We do talk about radio technology. It's called This Week in Radio Tech. But, there's so many times when radio and television technology are crossing just a little bit. And I think we're going to do a show in the future about ATSC 3.0 that I don't know if it'll happen or not, but if people who produce audio content want to have a distribution channel and they can't get a local radio station, and maybe they either don't want to do or they want to do something in addition to internet, ATSC 3.0 might be a way to get a bunch of audio channels on the air to consumers, to cheap receivers for free in pretty cool ways. That's a few years down the road. We'll be looking at that, though. But today, we're going to look at behind the scenes in media production. And to do that, we're going to talk about Intercom over IP. Seems you can do about anything over IP. We'll talk about Intercom over IP. I'm Kirk Harnack, your host of the show. I just realized I got so much junk behind me here. Holy cow. Yes, this is This Week in Radio Tech. It's TWiRT. You can see it there and there and there. I'm in the Telos Alliance studio in Nashville, Tennessee. And I appreciate the Telos Alliance. And my boss is there giving me a little bit of time on Thursdays to do this show where we can bring you some expertise and have some fun too. I just got word from Chris Tobin. He has been called away to do a video production of a music performance, a jazz music performance this afternoon. So almost at the last minute, Chris told me that he could not be here, but that's okay. I've got a question from Chris for our guest, and we'll get to that question in just a little bit. Let's bring in our guest. Our guest is a friend of mine. He's also a colleague, a guy that I've worked with for a good 2 or 3 years now. His name is Martin Dyster, and he's from merry old England. Hello, Martin. Glad you're here.
Hi, Kirk. How are you? And hello to everybody out there in TWiRTland.
It's good to see you. And I see you have a Rock Hall on the Air poster. What's that about over your shoulder?
It's one I picked up probably the first time I ever went to Cleveland to the Telos offices, and I went to the Rock and Roll Hall of Fame for the first time. And I saw that poster, and I just had to have it. So I brought it home, framed it up, and put it on the wall.
It looks good. It looks good.
To add to the rest of the detritus that I've got around the place here.
You're brave enough to show a treadmill in the background. I've got a treadmill too, but it's one floor up, and I'm thinking it doesn't get the workout that it should, and neither do I. Does yours actually get used? If you don't mind my asking.
Well, I tell you what. I mean, we're going to talk about Intercom, and the one thing that it's really good for is hanging belt packs on.
Oh my goodness.
Yeah. No, I mean it doesn't get the use it should, and anybody who knows me, and fortunately you can't see my lower half from here, but on the camera, but or middle down, it needs to get more use desperately.
As does mine, and it's one floor up, and you know what? It's even got a television built into it, so I can run videos on it, and I should do that. Okay, but you're a brave man to have it right there in the camera shot, and every time that we have a company conference call that you're on, there's that treadmill. Yeah,
I think it encourages people to think that I'm fitter than I am. Maybe I don't know.
Or I think one of our colleagues, sometimes I see a bicycle hanging on the wall behind him.
Oh, okay.
Yeah. He's trying to show off.
I mean, I've got a sword over my shoulder as well, and that gets more use than the treadmill.
So let's give our audience a little preview of what they might expect to learn about today. Intercom, and most of the people who listen to or watch the show are radio engineers, not everybody, and some do double duty. They also work in the television field or other video media production. And in radio, we haven't used intercoms so often. Oftentimes radio can get by just fine without intercoms. We have the occasional IFB in your ear, to a talk talent, but we don't use intercoms so much. In television, they're used all the time. I certainly have. But we're here to talk about the technology and the modern uses for it. So could you give us just a little taste, wet our whistle, if you will, for what we're going to learn about today? What can a person expect to walk away with today knowing that they didn't know before?
I think we'll probably talk a little bit about the history of intercom, where it came into being originally, how it's derived, how two-wire intercom first made its way into the broadcast world, certainly through various routes, and then how intercom technology has developed over the years. Certainly in the years I've been working in it, my experience goes back to the mid 80s when I first started working on analog comms, and then right up to date, winding our way through the years from the 80s up to where we are today, where the Telos Infinity system, my baby, if you like, has come into being, which is an all IP matrix-free comm system, which is really absolutely on the cutting edge of comms.
All right.
So, we talk about a few things like that, and maybe talk about phishing as well, if you like.
Well, okay. How about fish over IP? Is that FOIP?
FOIP. That'd be an interesting thing.
I know fishing is a cool, a good pastime of yours, so I'm eager to hear a whopper of a story by the time we're done today. Hey, This Week in Radio Tech is brought to you in part by my friend Josh Bone over at Max Connect. Now, Max Connect is not just some way to buy some data off of a 4G wireless hotspot. No, Max Connect is a service that uses this Cradle Point router, and they have some other models as well. And you can get their service either with AT&T, with Verizon. I believe they have T-Mobile coming on. And what you get as a broadcaster, as a customer of Max Connect, is you get prioritized data, prioritized wireless 4G LTE data. And that means that you can be in a stadium full of people at halftime with their phones on, checking their Facebook or sending text messages or doing a FaceTime with somebody. And the data is all getting used up, and you're not going to have much left for your broadcast if that's what you're using. But if you've got Max Connect, you've got prioritized data, prioritized over everybody else except first responders. Okay, let's give them the first priority. But I have used Max Connect myself in a number of different situations where I would not expect great data service from my regular telephone, and the Max Connect system worked great. I'm getting consistent 5 megabits per second. That doesn't sound like, hey, well, I can download, 20 megabits per second or 30 megabits per second. Max Connect, you don't miss a packet. That's the whole idea. And we've done whole video shows with Max Connect here on This Week in Radio Tech. And we've also done whole video shows for the Society of Broadcast Engineers in Las Vegas, where I thought I had a good, solid connection from T-Mobile. Nothing against T-Mobile, but it wasn't prioritized. And we ended up missing a lot of packets and having a bad video signal. We switched that over before the broadcast to Max Connect, and everything was perfect. We had a great video signal for the whole broadcast with Max Connect. It works off, as I said, 4G LTE. It can give you, Wi-Fi, but why would you use that? If you really want quality, you're going to use the LAN connection on here. Max Connect can also be a backup. If you're at a sports location or someplace you're doing a broadcast, you can use the WAN connection as your primary and use the LAN as a failover for data if you lose your primary. So Max Connect can help you out with studio transmitter links for live remote broadcast. You can think of other ways to use Max Connect. Go to maxconnectwireless.com. It's spelled funny. Take note of it. It's in the show notes, so you can go there yourself, maxconnectwireless.com. And this stuff really works. I'm so grateful for Josh Bone, who is a broadcast engineer, for making this service available. It's what we needed in the broadcasting biz. Hey, we're going to hear from Cal Rec. We'll be right back with Martin Dyster as we talk about intercom over IP.
CalRec's Type R is a modular, expandable IP-based radio system featuring 3 slimline panels, a fader panel, a large soft panel, and a small soft panel easily configured to give the operator full control. Layouts are saved and recalled quickly between shows. A single 2RU core with integrated I/O gets customers up and running fast, and that single core can power up to 3 independent mixing environments with no sharing of DSP resources. Available in 4 DSP packs, and as your station grows, larger packs can be added, enabling it to grow with you. Power to the surface is supplied via standard PoE switches, keeping cabling to a minimum. Type R is fully AES67 compatible, as defined by SMPTE 2110, which means that it is also compliant with NMOS discovery and connection management specs. All these features combined make Type R the most flexible radio console you can buy. Find out more at calrec.com/TWiRT.
Thanks a lot, CalRec, for sponsoring This Week in Radio Tech. We sure do appreciate it. Hey, Martin Dyster's with us. If you're just joining us, it's This Week in Radio Tech, and we're talking about intercom. We're going to get to today's modern intercom after a really short history lesson about how intercom got going and got started. So, Martin, why don't you start out here? I understand the very first intercoms were, of course, wired, but they even started I think you mentioned the word Victorian. These started back in Victorian times. Is that right?
Well, yeah. I mean, what we're saying there really is that the genesis of intercom, if you like, the germ of the germ of the use goes back to good old fashioned 2-wire phone, bell wire. And if you can, well, neither of us can think back this far, although maybe I guess I can think back to the late 60s. But when telephones came into being, whole communities would have a single wire that ran as a loop around a village, with anybody with a telephone handset that had enough money to be part of a party line would be able to communicate with people from their house on this shared cable. And it's actually where the word party line comes in. And I can remember just about mum and dad in the estate that we lived in just north of London back in the late 60s having party line phones before we had our own extension, and there would be a group of houses that would share essentially the same number or share the same line, so that when they picked up the phone, if they wanted to make a call, if somebody else is already using the physical wire, then they wouldn't be able to do that. And as the infrastructure expanded and it became more affordable, then of course telephone exchanges got into being, with a point where you would call your operator and your operator would plug you in to the right call, you know. But I was going to say, I mean, that technology then became the catalyst for simple communications on ball fields in the US, particularly American football. Coaches' communications from the stands down to the field. Obviously, with football and with most field sports, you get a better view of the flow of the game from up in the stands. And if you're coaching from up there and you want to make calls down to the field, then you needed a way to communicate. You couldn't keep running down, back and up and down. But they used 2-wire at stadiums, and then that became something that was used in TV in the not too distant future, in broadcast productions, not too far after that point.
Yeah,
and that's sort of the evolution went.
Those 2-wire systems, I guess that was just battery voltage and carbon mics and earpieces. I remember using one like that. When I was in high school, but this would have been the late 1970s, but it was an old, RCA everything installation at a university. And the headsets were those hard plastic. They were horribly uncomfortable. And the
Bakelite.
Yeah. And I think this had a clear plastic on it, and then the mic element itself, I guess, would have been a carbon element, and there was battery. As I remember, so. when you plug it in, it would be a real scratchy on the plug because there was DC on it all the time.
Oh yeah, absolutely. And those 2-wire intercoms are still out there, and they're still big business for comms manufacturers. I mean, the RTS 2-wire products and the Clearcom products still sell in big numbers. They're reliable. I mean, they're not great in terms of audio quality, but they do a job and they're inexpensive. So that technology has not gone away.
So as a radio guy, I don't have a whole lot of exposure to using intercom, little bit of, I guess, sort of IFB. And I was always a small, medium market radio guy. I wasn't in the big markets. I know here in the U.S., I got to visit WGN in Chicago, WGN Radio, and they have quite a nice intercom system. But what are some of the other places that intercom is used? I believe theater is a pretty common use of intercom.
Yeah, theatre's a huge user of intercom. So live events, fixed installs in places like theaters and music venues. I mean, every touring show, whether it's touring theater or a rock band that's on tour, they'll use intercom now to link the communication channels for sound, for vision, for the lighting guys. The same is true in theater as well. You need to get your cues. You need to know what's going on in the show, so your spot follows the right person, or you cut the right lighting cues, or when the band's going to come on stage, so you can kill the house lights and run the video and put the fader up, or whatever else it is. So intercom is all around us all the time. In many, you won't go to a show or an event of any sort. It's in security all the time. You see the protection teams that are running around with dignitaries, putting the finger on their ear or talking to their wrist. Because they're on a comm system, and it goes right the way down. You see it in restaurants now. You see the staff will be on a comm system getting a call that the burger for table 3's ready or something like that. So intercom is everywhere, absolutely everywhere. Shopping centers, restaurants, you name it.
So for several decades, intercom systems in the broadcast world, and I guess other places too, have utilized some kind of a central switching box to determine who was talking to whom. Do you know when did this come into play? When did it quit being a party line only situation where that was your choice, and maybe party line 1 or party line 2? When I was doing that TV in high school, we could choose line 1 or line 2, and we only used line 1. One day I accidentally switched it over to line 2, and nobody could hear my commands, to camera 2, truck left. What are you doing? And nobody could hear. So there was those simple systems where everybody's on the same party line. When did something more sophisticated come along?
So my background goes back to the mid 80s when I started working for a company called Drake, and Drake was a UK-based intercom manufacturer who built early matrix systems in the 80s. I believe that McCurdy in the US were one of the innovators, one of the first companies to come out with a matrix-based system. The early matrices were pretty simple in terms of electronics. If you imagine the key part of an intercom system, is much like any audio router, is taking a voice and then directing it to the right place.
Sure.
And so that communication has several parts. An intercom panel has a microphone of some sort. That could be a preamp that a gooseneck mic is plugged into quite typically, or it could be a headset connector, or it could be an external microphone. That has to go down a bit of wire from the panel down to the matrix. The speaker or whatever the listening device brings audio back the other way. And in early matrix intercom, the keys on the front, the lever keys, paddle switches, push buttons, whatever type of technology was used, ultimately when you press a key, that information that relates to the mnemonic that's over the top of the key that says I want to talk to Dave in sound, when I press that button, that command has to make it down a piece of wire, has to hit a cross point, an FET switch or a transistor or something like that inside the matrix that takes your microphone and routes it out to the line that goes to Dave's speaker. And they really are as simple as that, or early intercom systems really were as simple as that. A huge frame full of input cards, then full of crosspoint cards, and then full of output driver cards. And that's what the Drake systems were like, and I believe that's what the McCurdy's were like. Pretty much the same thing.
So I guess a lot of us have at least seen an intercom panel, and you mentioned these toggle switches. So it's been pretty standard, I guess, for a lot of years that you have a mnemonic, as you said. You have a label as to who you're speaking to. And then you can toggle the switch to either listen to that person or talk to that person. And I guess did it come along eventually that you could lock the switch to locking on to talk or lock to listen?
Yeah. I mean that's sort of how the history goes back. The switches that were used in the early Drake systems were taken from telecoms applications. They were called PO switches from the post office, because the post office used to run our telephony in the UK. And those toggle switches were about the paddles about an inch long or so. Depending on the type of switch you had, they would either have an action that was momentary, so it had a spring that pushed the lever back, or it would have a latching position, so when you flicked it up, it would stay latched up, or would stay latched down. They would have multiple contacts on them, so that you could have different actions on them, and they continue to be the standard for a very long time. And in fact, if you look at the Infinity system, it still uses those lever switches. The other major brands that are out there, I mean, particularly RTS Telex, who's the company in the US that's prevailed for the longest, I think. RTS Telex panels, their bestseller, the KP range, and the ones that have come after it, the next generation, maintain that kind of switch functionality, and it's really the mainstay of functionality in the US is that kind of up to listen, down to talk. Now it's all electronic, of course, so the listen action can be flick the key up very quickly, and it'll stay in a listen position. Push the key down quickly, and it'll stay locked in talk. Or push it and hold it and then release it, and it'll come back up in a non-latching form. And that's kind of the default conditions for most intercom systems. In Europe, where other brands have come later, Riedel is a good example. Their early systems, in fact, current systems as well, centered around using push switches. And that's historical, really. The European market accepted those, whereas in the UK and the US particularly, we got used to the lever key or toggle switches.
Now you're being very specific about this, and I think there's a reason why, and that is how people use intercom panels. They want to be able to use them with just their peripheral vision. They don't want to. Somebody's using an intercom panel as opposed to a belt pack or a little wall speaker. Don't they want to be able to use it without having to focus on it? It's incidental. They got to hit the right button.
Yeah, absolutely. I mean, intercom is by design and also by the use case. I mean, by the way it's used in workflows, you want it to be almost a transparent part of the process. As easily as I'm talking to you on this microphone and you're talking back to me, you don't want the way that you use intercom to get in the way of your creative process. Right. You want to know by muscle memory that when you reach down to the belt that you're pressing the talk key, you're not even thinking about it. It's like driving a car, or playing the drums or something like that. It's all muscle memory. You know where everything is instinctively. So, I mean, when we talk to people, I mean, I was in systems integration for years, building intercom systems, designing facilities. You talk to customers about the configuration, and they would always have their their primary keys, the ones that they use all the time, the people who are the destinations they talk to the most, like the production talkback, the entire team, or depending on who they are, maybe it might be the cameras, or if you're in sound, it might be the boom operators, or in lights, it might be the spots, or whatever. Those keys would always be in one place, and often it would be the bottom left-hand corner of a 32 key panel. There would be that area, and that's where they reach for. I guess it's like playing the piano as well, is another good analogy. You know where your middle C is, and everything references off that. So
yeah.
So you drop, and also now, having spent the last 5 years developing the Infinity system and talking to customers with a different hat on, I've asked the question before. What kind of mortality do you get on your switches? And they've said repeatedly, I've had customers say the same things. That switch always breaks. So why does that switch break? Says, that's the one I'm bashing all the time. That's the one I'm hitting.
Well, imagine that.
That's the one that I'm shouting at the talent, or whatever it is. But you're right. This is a piece of equipment that is used without thinking about, and it has to be like that. And it's probably one of the reasons why, despite the fact we have great touchscreen technology, why certainly intercom in broadcast, touchscreen versions of panels have never been very successful, because when you put your hand down to them, you've got no reference points.
Yeah.
You've got to look at them, because you don't feel that connection of touching a switch.
Which means you're not looking at something else that's probably your bigger job.
You should be looking at the monitors.
Right.
Yeah, or you might be looking at a script, or you could be looking at many things. Probably a monitor if it's TV. Making sure what's going out is right, and you want to talk to the talent. You want to reach down and know that you've hit the right button. So yeah, it's like that.
So just to spend a couple more minutes on the old type of intercoms, you were telling me in a conversation in the past about a 32 position panel. You could talk to 32 points, and the number of wires that were involved with this, because not only do you have the switches that have to signal back to a central matrix, but you also had tally lights. Tell me about the incredible amount of just sheer wire that would go to a traditional intercom panel.
Yeah, so the example I was thinking back to is one that I worked on at Drake, and I became the project lead on that one, and it was for a company called TV South, who are an affiliate down on the South Coast, one of the independent TV channels down on the South Coast here, that's merged into another Meridian Television, they're called now, whose intercom I also installed. But TVS had a particularly large system, multi-studio system, and back then you had to sit down with a hand-drawn spreadsheet and work out how many keys every member of the production team had. You had to you had to figure out how to how to do that. And if you take something like a 32 button panel, which back in those days would have been 3 rack units at least.
Yeah.
Because of the size of the switches and the fact that above every switch you needed to have a tally light to say that something's there to listen to. There'd be a green light flashing to say, listen to me, flick it up, go steady, or a red button to tell you that you're talking. No LCD displays or anything like that at that time. So if you think about the logic behind this, every switch has 2 actions, has up, down. That's 2 wires for every switch. Every switch has a tally lamp. So you've got the incoming tally. For listen, you've got the talk tally to tell you that you've made the cross point and you're talking. You've got DC supply for the lamps, which and then you've got commons as well. If you multiply, well, you won't have DC for every single lamp, but you need that coming into the panel. But if you multiply those circuits up, along with the technical ground that has to go all the way back on a large panel, you may end up with something like 5 56-pin EDAC connectors wired with 20 pair cable, and 5 of those per panel. in a system that could have 30 or 40 panels, all of the same size. And you imagine what the back of the matrix looked like. The matrix itself could be, in that instance, maybe 40 rack units high, or 35, 40 rack units high, full of EDAC connectors on the back, that each one of those connects to a panel. And I'll tell you a little anecdote about that particular system. When it went in, we had a bug. And it's not a software bug. There's no such thing as software in this system. We had an instance where the customer used to call us and say, lads, we've got switches on here that keep turning themselves on. And you wouldn't believe it. We'd drive down to the south of it, down to the south coast where the studio was in Southampton. And we'd have to sit there for hours waiting for these switches to just turn themselves on. Now, they wouldn't move, but there was clearly a grounding effect happening between the contacts of the switch, and you'd automatically think, okay, there's a solder splash or something like that. There's a fine piece of wire. It's not been trimmed properly when it's been wired. There's something in there. And we'd take them apart. We'd drop the front open and start peering in there and try and figure it out. You'd desolder it. You'd resolder it. You'd clean everything up. You get a solvent and make sure there's nothing there. You'd run a knife right the way through the connector to think, okay, it's absolutely clean. Then you'd measure it, and there would be, there'd be infinite ohms across this connection. You try the switch and go, yeah, it's closing properly. And you'd sit there and say, I think we fixed it. Go away again, get the call 2 days later. So they keep coming on again. And I'll tell you what it was, and it took us a long time to find this. We had a batch of switches that had some metal particles inside the plastic insulator between the pins, and as it warmed up, it started to conduct, and it just crept from into hundreds of thousands of ohms, from megohms, kiloohms, and eventually down to a point where it could pull a transistor on, or a FET switch on. And it took forever to find that fault. It was the most unpleasant fault I've ever had to find on a systems build, but that was horrendous.
It sounds like improper manufacturing of these insulating layers. Yeah.
Oh, it was. Yeah. And those switches cost a lot. I mean, those things were $30 a switch. You can imagine how much those systems cost.
Oh my goodness. Wow. So for every panel, you had many, many pounds of cable. A big. Do you have a good sized conductor, a good sized cable, or several cables?
Yeah, you have a 20 pair. We'd call it PSN cable. I don't know what the equivalent would be in the US, but typically we'd use a 20 pair. So you've got 40 cores. On an EDAC connector, you'd always wire it in pairs. You'd never use the middles. We had conventions for EDACs, the way they were wired, so you'd use either a 20 pair or a 25 pair, and you'd have maybe 5 or 6 of them for a large panel. I've probably still got plans somewhere.
A lot of us engineers who've been around a while, we do think fondly of some of the good old days, the troubleshooting that was normally pretty straightforward because there was no software. It was, just like you did with those switches. You'd flow the solder, you'd make sure there was nothing in the way, and you'd think, hey, this is fixed. But we're going to talk about moving into newer technologies after we got a quick commercial break here, and then coming up next, we're going to talk about a bit about the interim, what's happened between those days of the switches and where technology took us for a couple of decades with some electronic. But then we're going to focus really on doing all this over IP, and not just doing it over IP, but also eliminating that big 40 rack unit job or whatever size it may be, eliminating the central matrix, because those things can get expensive and they're absolutely proprietary. So we're going to talk about getting rid of that and having a really smart intercom system that just works over a computer network. That's coming up this week in Radio Tech. I'm Kirk Harnack, your host. Martin Dyster, who is the product. What's your title these days, Martin?
Sorry, I was just take a slug of water. My title is what is it? Vice President of Business Development.
There you go.
Yeah.
I know you as the guy that knows all about intercom. So I guess I'll try to remember the right title. It matters not what your title is so much, does it?
No, I mean when I joined Telos, I couldn't really have the title of intercom specialist or anything, because we didn't want any of the competition who were friends, ex-colleagues, and suppliers of mine to know what the hell I was doing. So there was a bit of subterfuge there.
All right. Well, hey, we'll be back to talk to Martin in just a second. This Week in Radio Tech, episode 475, is brought to you in part by my friends at Angry Audio. You know, the Studio Hub brand, there was a rumor, and some people were told over the phone, no, Studio Hub is closed. We can't sell you. We can't get any more of their Studio Hub cables or adapters. Well, that was true for about 10 minutes. And then the folks at Angry Audio picked up the whole line. They even took over the manufacturing, the same factory, the same jigs, the same molds, the same people are still making the Studio Hub standard adapters and cables. Here's one in my hand right now. If you're watching on video, you recognize these. This is a great way to get audio, whether it's digital audio or balanced analog audio, out of or into your standard equipment and get it wired easily into a lot of today's modern audio over IP devices, like, for example, the Axia X nodes. So many devices these days that are converting into and out of an audio IP network, they're using the RJ45 connector, and they're using the Studio Hub standard. Here's another example for you. This is a 6-foot long cable, and on one end, you have two XLR connectors, stereo, left and right. You could use just one of them if it's AES audio, digital. And on the other end, you have a RJ45 connector. And this is wired with audio cable, but it's wired properly into the RJ45 connector to follow the Studio Hub standard. And this is just a delightful way to wire your studios. I got to tell you, I've wired a number of studios now this way with Studio Hub, and it just makes things go click, 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 and you're done. No more soldering. It just clicks together. And how, okay, well, this is a 6-foot cable. What if I need more? Well, just use a longer cable. Use a longer Cat5 cable. Use one of the adapters. There you go, some on the screen right there. You can get these Studio Hub adapters that go from RCA connectors. Of course, that would be an unbalanced connection. You probably want to take that to a balancing circuit. By the way, Angry Audio can help you with that as well. You can get these and bare wires if you want to put your own connectors on. XLR connectors. You can get the mini XLR connectors, as is found on some satellite receivers. You can even get the mini 1/8-inch connectors. You can also get these with the RJ45 male connector already attached, as I just showed you with that blue cable. Available a couple different ways. Hey, if you order the gray cable with the female RJ45, right now, ask your dealer for a free cable from Studio Hub. This is it's all packaged and beautiful. It's insulated. It even gives you the Studio Hub wiring standard on the package here. You get a 7-foot cable free with every purchase of the female type, because you're going to need an RJ45 cable, a Cat5 cable to take that. And also, the folks at Angry Audio are also making available something that a lot of folks love. This is a headphone amp from Studio Hub. So Angry Audio has these now. This is in the Decora format, so you can put a light switch panel over that, a Decora light switch panel. These fit great into your audio consoles. You can also get a plastic panel to hold this up, a plastic angle bracket. Power and audio come in, and of course this is the Studio Hub standard, so you can just take your Studio Hub and plug it right into here. Let me click. There you go. It's wired. It's done. There are 8 connections there. I think 6 of them are used power and ground, maybe 7 of them, power, ground, and left and right audio. It's all available at angryaudio.com, and your favorite Angry Audio dealers should have these. If you can't get it that way through your dealer, go to angryaudio.com. Check out all the cool stuff they have, including their new Bluetooth audio gadget. Thanks a lot, Angry Audio, for sponsoring This Week in Radio Tech. I'm Kirk Harnack. It's episode 475. Our guest is Martin Dyster. He happens to be a colleague of mine. He's become a friend, and he lives in England, and he knows all about intercoms. Martin, you've been telling us about the history of intercoms. You gave us an idea of some of the bad old days of intercom with just huge numbers of cables. And now we've got intercom over IP. We'll get to that. Give us just a little elevator speech about what was the bridging technology or technologies between the hardwired stuff and the networked audio stuff. Where did that land for a while?
So I guess the obvious pinch point with the design that I was talking about before, where you've got all these control cables, one control cable per cross point, whether it's talk or listen, is just that, it's control. So the natural evolution of that was to turn parallel control, or GPIs essentially, or just closures, into serial control. So the first step towards that would have been proprietary control, or RS-232 or RS-485.
Yeah.
So the audio has stayed the same. I mean, the audio component coming out of a panel is still essentially mono audio from a microphone, maybe stereo or maybe dual mono if there were two parallel sources, or two separate sources if there were AUXs on the back of the panel or something like that, and then feeding back to the speaker as well. That could be either a mono coming back to the panel, but that transferred from those large number of EDAC connectors into a D9 or a D15 for serial communication. And that's the way it went. That was the stepping point between analog and individual control wires and IP or proprietary audio over Ethernet.
So these panels you speak of, they still talk to a central matrix back in a rack room somewhere, right? They didn't have any real intelligence themselves. They were just displays and controls for a matrix system.
Yeah, exactly. A panel would be pretty dumb. It would, while the audio was still analog, even though the data was digital, the matrices had shrunk down because you didn't need all that LAN for the connectors and all those additional input and output boards that you had before, but and all those crosspoint boards, because it was then being handled by serial data. But the panels themselves, if they had ever expanded in size because of the size of connector on the back, which is a terrible reason for the panel to be bigger, then they shrunk down. But also around the same time, you start to get into switch technology, which is more manageable. There were versions of those toggle actions on switches. I believe we used to call them shadow switches back in the Drake days, but there were different switch types that mimicked that action that came into existence, and also we started to use LED displays.
Oh, sure, sure,
and then LCD displays. But that kind of transition happened in the late 80s at Drake, moving into the 90s, and honestly, a lot of that technology hung around for a long time from the 90s. Didn't really change a lot. A lot of fine tuning of panel designs, better switches and stuff like that, better displays. But the fundamentals of having an analog connection or maybe an AES-free connection and serial data back to a matrix of some sort was around for a long time. And once you get into digital audio, then of course you get into time division multiplexing inside the matrix, and so the matrix itself becomes more efficient. But you still have those restrictions that you had before: the physical size of the matrix, the ability to connect a finite number of devices, and also the bus structure of the matrix itself was a restriction, meaning that a matrix system could only grow to a certain size before you had to get another matrix and then figure out how to trunk matrix 1 to matrix 2. If you were getting into larger systems.
I guess though, one interesting thing about a matrix system, as opposed to some of the original just complete party line systems, with a party line like was the original intercom, you had one choice of who to talk to, and that was everybody. Unless you had a couple of parallel party lines, you could divide it among a couple different groups, and you would attach people to the right group. But along with the matrix technology, whether it was analog circuitry or digital circuitry with a TDM backplane, you could, I guess, create whether I want to talk to one person. I've done weather on TV. So yeah, the director wants to talk to the weather guy and tell him to hurry up and wrap it up now. Right. Or you may want to talk to everybody, or you may just want to talk to the camera operators, or you may want to talk to the overhead speaker system. Bob, get to the studio now, that kind of thing. So you had different groups that you could talk to. You could define a group in electronic system. And that's been true now for at least a couple of decades, right?
Yeah, I mean, it became easier to do that. You could do that with the old systems, to be honest. I mean, that kind of design to make that happen was extremely complex. I mean, what you would end up doing is you'd sit down and have to figure out who groups and party line equivalents were at the time. Who of the people that are connected to this matrix need to be talking to each other in a conference at one time, and who is a group. All the cameras might be a group. Talk to all 6 cameras at the same time from one key. Now, if you had 3 or 4 panels that were doing that, then those controls can't just be wired together. They have to go through a gate. So if you would have to put another card into the frame somewhere that was full of logic, and these could be custom built. You would have a card that literally has logic gates in chip form on the board, using what we used to use it's not a printed circuit board, but a special kind of with a strip board, a development. Yeah, you'd use a wire wrap board. And so if you've got 4 people talking to a group at the same time, you would bring their 4 talks in, take them down to the OR gate, take the output of the OR gate, take that to the FET switch that then talks to the 4 cameras, and you would do it that way. So you do some incredibly complex stuff using discrete gates, discrete Boolean logic.
My head's starting to hurt. Oh man, I can just imagine all the work involved here. Can we move? Go ahead and move on to how we do this today.
So that became very much easier now. So the catalyst for the Infinity system was somebody coming up to me at NAB in 2014, a guy called Roger Charlesworth, who I've known from the industry. He's leads up the DTV audio group out of New York. He's from Broadway Video, worked on Saturday Night Live for years. And he said, a bit about intercom. And I hadn't been working in intercom for some time at that point, but he said, quite a bit about intercom. Yeah. He said, have you ever wondered why people still use matrices, why they don't do everything with IP? Because we're so used to being able to have conference calls on Skype and stuff like that. Why is that technology, SIP particularly, why is that not utilized in comms? And you think about it for a while, and there's no reason why you couldn't do it, unless maybe you're a comms manufacturer and you've got a whole legacy family of customers to support and product lines to support. I was working for a company called TSL at the time. Roger said, do you think TSL would be interested? I don't think they're the right company. They don't have a comms heritage. But if I was going to do it, then a company like Telos, who have an IP heritage and an audio heritage that goes back for decades, I said they would be ideal. And that's how it came about. It was Roger putting me together with Telos. I mean, it's not like I didn't know them. I knew the linear acoustic side of the business, but putting me together with the Telos Alliance and coming on as a contractor to look at the technology that had gone before with the IP product ranges, the consoles, and actually the early Axia IP Intercom system, which was developed for the radio industry, and figuring out how we build something that's fit for purpose for the broadcast television and all these other vertical markets that exist out there, and that's how Infinity came about. So the fundamental difference with Infinity and I actually pulled up before we started this call. I pulled up the mission statement. This is what it reads: to revolutionize broadcast communication through the evolution of disruptive and innovative standards-based technology. And that's something I wrote when I started at Telos, and said this is what we're going to do, and that's what we set about doing, using that set of criteria. And the Infinity system does just that. And one of the big banner headlines that we had was, we will not build a system with a matrix or any kind of centralized core to it whatsoever. It will be just panels and other devices sat on a network, passing audio using standards-based technology, so using AES-67 in our case, and will revolutionize the way audio intercom works, because we can then build. It's called Infinity for a reason. I mean, theoretically, if you're an incredible network designer, you could build a system with thousands and thousands and thousands of panels. You'd never have that restriction of having a matrix in the way and running out of ports. And that's what we did with the Infinity system.
So let's chat in our remaining time about, let's try to give people an idea of how the technology works. Of course, a lot of our listeners are at least familiar with audio over IP. So you've got devices that take audio and create a stream, an AES-67 stream. Typically that stream, it's a multicast stream. So it goes to a central core router, just a standard off the shelf, Cisco or similar router, and it stops there. It has a multicast IP address. And then it gets routed by virtue of the fact that some other device, or maybe the same device, but some other device on the network requests, hey, I'd like a copy of that stream. Send that to me, at least for a moment, or until I tell you to stop. And so we're letting a Cisco switch do some of the job here. It's not all the job. And I think this is what's kind of key. We're letting a Cisco switch manage handling. Oh, you want that piece of audio? Okay. Oh, you want this audio? Oh, all four of you want this audio. Okay. And this is what a multicast switch is designed to do. They do this all day long with video and all kinds of things. And certainly with Livewire and AES-67 and Ravenna and WheatNet and all these different standards, they do exactly that. So as far as transporting audio and making a single piece of audio go to one place or go to 1,000 places, that's what a switch can do. But there's more to the story than that, because sometimes we want several pieces of audio to come together, to mix together and go somewhere, or people to talk easily, like as a party line. So, one to many is easy for a multicast audio system to do, but many to many at the same time on the same audio, that requires something that I guess you call rendering. It requires mixing. Could you tell us, and that's kind of key to getting rid of that central matrix, is where's all this audio going to get mixed together so that everybody can hear what everybody's supposed to hear? Talk to us a bit about that kind of technology and how that's integral into what the folks at Infinity have done.
Yeah, sure. So the fundamental part of that is we had to recreate the nature of a matrix somewhere. So what we've done, the short story is we've put DSP into every single device that's on the network. Every device that has an Infinity logo on it. So if it's a panel or a belt pack, an expansion panel or a desktop panel, any of the Infinity pieces has a DSP core that is the equivalent of a reasonable size matrix. I mean, to be absolutely correct about this, if you took an Infinity panel like the ones that are over your shoulder there, then each one of those is something like a 64 by 32 routing matrix built into it. So if 5 people want to talk to that panel at the same time, or if it's subscribing to a conference that has many people and there are 5 active talkers at the same time, that panel is perfectly capable of mixing 5 sources together at the same time.
Hey, I tell you what, if I just realized we could do a very quick demo here. If you'd cut full screen to me and let Martin, you talk, but I want to just show that what this panel does. If you want to full screen me there, Suncast. Is son guest listening? Did he leave the room? Maybe we'll do this in a minute. I want to show this on video. I've got this panel set up. Tell you what, we'll wait for Suncast to full screen me, and then we'll oh, there we go. Okay, here we go. So I've got some audio here. Now this I'm not talking one panel to another, but I've got some audio on my network here. And so now I'm switched into listening to it. And here's another one.
Supports the creation of a federal commission to develop proposals to address the continuing.
So what was I doing just right there, Martin?
Well, you're subscribed to those two multicast streams, and what you're doing is just switching between them. I mean, you could have listened to them both at the same time. It wouldn't have sounded well. It would have been an interesting mashup, I guess. But on that panel, if you
that's pretty terrible. I mean, they both sound clear, but they're together.
Okay. Yeah, exactly. I mean, I've done this. One of the tests that I've got the multicast. Sorry, not multicast. I've got the multi-track audios of Bohemian Rhapsody. I've got the 24-track masters in WAV file here. I can put them on my Livewire driver, give them all a name, snare, bass drum, and then the Infinity panels behind me will recognize the name of each of those tracks, and I can listen. I can mix Bohemian Rhapsody on my panels.
You're a wild man. That's crazy.
because it's perfectly capable of listening to multiple sources. That's not a high number for Infinity 24 mono tracks. Well, it's 23 because there's time code on one of them. You don't really want to hear that, but so you can do that. But I mean, going back to what you're talking about, when you're talking about mixing things together in Infinity land, that's easy. If all you've got are Infinity panels and belt packs, then that's pretty straightforward. They mix together all the people that talk into them at one time. They can talk one to many or many to one, and that's a breeze. And the more panels you've got, the more power you've got, because you keep adding these little virtualized matrix blocks to your network. Now, if you've got something connected that isn't an Infinity native device, like an X-Node, for example, or an outgoing AS67 stream to a third-party piece of equipment, and you want that output to have the capability of listening to multiple streams, then you have to mix that together somewhere. And it could be an IFB. That's a good example. 3 people want to talk to the talent at the same time. That has to be a mix, and you need a 3-into-1 mix to do that, or a 4-into-1 mix, or whatever it is. So when you define that within the configuration tool for Infinity, it is self-aware. It looks at the DSP that's available on the network, and it says, I'm going to put that mixer in that DSP core on that panel over there, and I'm going to put a backup on another panel. And the outgoing stream will be generated from inside one of the panels. It's hosting this mixer, and it will subscribe to it. Simultaneously, it will subscribe to the secondary. So if the primary drops off, it will switch over to the secondary and pick it up.
Wow.
So you've got a handover situation, and you have a continual backup facility for the Infinity system. But that only comes in when you're connecting externals of any sort, and only outgoing externals as well. Then you need this. We call it the render budget, because we think long and hard about clever names, and that's what we thought of.
I think it makes perfect sense. The render budget. Yeah.
I probably would have called it a mix engine, but then I'm not a software developer, fortunately for everybody. So the software guys called it renderers, and the Infinity system generates renderers when you add external connectivity for anything, an IFB or going off down a tie line, or going to a VoIP codec, or whatever it does.
So Chris Tobin couldn't be with us today last minute, but he did have a question I'll pass along to you. You're talking about external equipment, and Chris often has a need to take an intercom system and hook that up to a land mobile radio, like a two-way business radio. And that radio is going to have an audio input, an audio output, and it's going to need a signal to key the radio to transmit. And maybe a signal that, hey, I'm giving you a squelch, an unsquelched signal. How would you connect that to an IP-based system like Infinity?
So much like the old key systems that we talked about earlier on, the ones from the 70s and 80s, you can associate logic to a key. So actually, I should rewind a little bit. The first thing you have to do is convert IP to analog, and convert analog back to IP, so that you can have that bidirectional 4-wire connection to your LMR. At Telos, we use X nodes, and some of the listeners may well know what an X node is. So an X node is a baseband to IP conversion tool. There are many others around from other brands, and if they use AS67, then we can connect to them too. So the audio connection is relatively easy. You create a source and a destination pair that are converted from and to the analog audio that will then go into the back of the LMR transceiver. With respect to firing the transmit function, Infinity allows you to connect a good old-fashioned GPO to a key, to any of the any direction of travel of the key. So you can connect a GPO to the push action, which would be your push to talk, and that will transmit a GPO. You can use, in that instance, you'd probably use one of our GPIO X nodes, part of the X node family, and you would wire that GPO into your LMR. And so when you want to talk, press the button, it opens the audio up, which is converted to analog, goes into the LMR. At the same time, you're firing a closure, which hits the LMR and puts it into transmit mode.
So one other question that, if I think if Chris was here, he would have thought of it, or I would have. What about putting telephone callers as part of your intercom system? So you've got reporters, remote IFB, people calling in. They need to be, they need to hear the producer director in their earpiece. How is that handled in an IP system like this?
So the obvious answer to that is using the family of products from Telos anyway, is the VX system, which is the SIP audio over IP broadcast engine that's been developed over some years now. And that allows you to connect your SIP service into the VX, which is kind of like having a bucket of hybrids. It's a term that we use internally that you probably heard. Yeah. But it's the VX is now VX Enterprise is a one new box capable of acting as anywhere from 8 to around 100 and something hybrids. Digital hybrids.
Yeah, it
converts to AS67. The Infinity system sees the AS67 and treats it as an incoming source and destination pair.
Okay, so you can take incoming callers, and I guess within something like the Telos VX, you could make an outgoing call and assign that a position within the Infinity intercom system.
Yeah,
right?
Yeah, precisely.
Okay.
I mean, as an allied product to the family, there's a control API within the Infinity system that's a couple of software revisions away from giving you full caller access from a panel, so the ability to dial from a panel straight out.
And to
receive. Yeah, I mean, at the moment it auto answers and it puts the caller straight on your keys. It has a Vox detector, so it'll flash at you to say there's somebody coming on such and such a line. You key up to listen, or you have it auto listen, and you're good to go. So we have a lot of people using it that way.
So I'll tell you what, we're going to take our last quick commercial break. And Martin, I wonder if when we come back, if you could, if you have anything handy for show and tell, if you have a belt pack or something like that, and then maybe you give us a couple of resources. Obviously, probably the Telos Alliance website, any white papers or things like that may be found there. We'll finish the show up though with a couple of resources that people can go to find out more about intercom over IP, and interestingly, doing away with that central matrix. I'm Kirk Harnack. I'm talking to Martin Dyster of the Telos Alliance, and he is definitely our expert on intercom and this whole new idea of doing it not only over IP, but doing it without a central matrix. It's pretty cool cool technology, integrates with other AES-67 gear. So it certainly is where broadcast is going with everything over IP. Hey, our show This Week in Radio Tech is brought to you in part by our friends at Broadcasters General Store, and they represent broadcast tools. Now, if you're a broadcast engineer, I know you've dealt with broadcast tools for years. And if you're like me, you know that broadcast tools equipment, no matter what it is typically very reliable and very efficient and very compact. The chief engineer there, Don Wingett, really knows his stuff when he designs a piece of equipment. Well, he's designed something that's kind of interesting, and that is the ProMix 4. Now, the ProMix 4 is a small, and it's diminutive. I mean, it's small, a portable little audio mixing console. Now, it's analog. It's a kind of old school with some new ideas in it that make things work very nicely for you. Now, it's mono. It's not a stereo mixing console. You say, what? Why would I buy a mono console? Hey, if you're going out on remote, you're going to do a live remote broadcast, you want something small and simple to take with you, the ProMix 4 from Broadcast Tools could be exactly what you need. It has 3 mic inputs, and they're those nice inputs, those Neutrik inputs that are XLR or quarter-inch tip ring sleeve. So you can do either one of those. It has a 4th input. It's got an auxiliary input. It's also got a USB connection, so you can connect it to your laptop computer, and that can be the way that you get audio from the ProMix 4 to your laptop, and from there, maybe you're using Skype or some other IP connection to get back to your broadcast facility, get the audio back, and you can also mix your PC audio in with audio in the ProMix 4 using that 4th input. It's got an IFB volume control. It's got headphone volume controls. It's got pan controls. It's got just what you need to do a small broadcast with 3 mics and an auxiliary input. It does have also one monaural balanced line level input, and it's also got a mix minus output. So if you need to have a local codec or hybrid on site, well, you can certainly do that with the mix minus output. It has a LED audio output VU meter. It does have the full duplex talkback capability. And there's also an on-air tally warning light relay output. Man, it's got everything you'd want for a little small studio, especially one that's portable. If you've got a newsroom, this would be ideal for a newsroom as well, where your audio is likely to be mono there all the time anyway. Here's something else interesting. Broadcast Tools makes this headphone system called the AHR1 Plus, and this plugs right into the AHR1 Plus headphone system. So to work with other things made by Broadcast Tools to give you a more professional layout and a more professional studio. I believe it also has a small audio limiter in case you've got an exuberant on-air talent, who says something loud like, he shoots, he scores. That can be pretty loud. So check it out, the Broadcast Tools ProMix 4. You know what I really like about Broadcast Tools? They solve problems. And I guess I've been using Broadcast Tools gear for probably 25 years or so. Remember, I used to use them for switching satellite feeds and just remote controlling satellite receivers was some of the first stuff I used. Never once had a problem. That's why I like Broadcast Tools. The stuff is really built well. And Broadcast Tools supports our industry very, very well. You'll find links for local contract engineers in your area. If you're having lightning damage trouble, links to Polyphaser and ITW Links and other companies. Don Wingett and his crew there really, they've been in business for 30 years, and they really love the broadcast industry, and it shows. You can check out Broadcast Tools gear by going to Broadcasters General Store at bgs.cc, or give them a call. I've got this number memorized, but you can find that on the website, 352-622-7700 for Broadcasters General Store, and that's where you can get Broadcast Tools gear. Thanks a lot, BGS, Broadcasters General Store, for sponsoring This Week in Radio Tech. And thanks to Don Wingett at Broadcast Tools as well. Hey, it's Kirk Harnack and Martin Dyster with the Telos Alliance. We are just wrapping up this talk. We've talked a lot about the history of intercom systems. I find it fascinating that some of the first ones, were kind of citywide. If you want to think about a party line, they kind of were. But then we brought that party line concept into the broadcast facility, and I actually used one of those back when I was a child, directing TV shows. And now we have the whole thing over IP, audio over IP, and even better than that, because it's all on a network, we're able to make smart devices that attach to the network and actually talk to each other And if I understand right, Martin, these devices have a little bit of contention's the wrong word, but they decide, hey, you're going to render these people, and you're going to render these pieces of audio, and all that happens automatically under the hood, and you don't have to worry about it. Have I got that story kind of right?
Yeah, it happens what's the word? Automagically.
Yeah, automagically. Yeah.
Yeah. And I mean, you can find out what's doing what if you know your way around the sort of back end system, but generally speaking, that's the kind of special sauce that customers don't tend to want or need to know about. But that's what's going on when you're connecting external audios, stuff like that's happening in the background.
Hey, we're going to wrap up the show in just a couple of minutes with some resources, but there's one thing we didn't talk about, and that's programming the system. Now, I have heard of, I haven't programmed intercom myself, but I've heard of intercom systems that required lines and lines of code to get them to do what you wanted to do. In other words, you would hire somebody from the manufacturer with a laptop to stay at your facility for a while and make it work the way you wanted. Oh, heaven forbid if you want to make a change. How do you program this AOIP, this intercom over IP system called Infinity?
One of the things that we wanted to do when we set out with to design the Infinity system was to demystify programming it. We wanted to build an intercom system that's fit for the modern age and fit for an industry where, let's face it, the older guard like myself and me. Yeah, I was trying not to say it, but we're not going to be working in the industry forever, and a new generation's coming in, and these are people that understand IP better than we ever will, that use modern technology all the time, and are used to applications on their phones and on their devices, and even on their refrigerators maybe that are very user-friendly, that are designed for anybody to be able to pick up and start using. And that's something we wanted to do with the Infinity system from the outset, really. So the software team that were responsible for the dashboard configuration software didn't have any prior experience of designing a tool like that for an intercom system. And I didn't dictate to them either. I mean, we gave them a relatively broad, in some cases probably slightly too broad, remit of what needed to be achieved, but we didn't pile on lots of examples of competition's intercom systems. We didn't define what the pages should look like, except within a fairly loose scope, so that when they went at this, and these are people that are very highly skilled at designing user interfaces, when they went at it, they had a clean slate, and they had the remit that we had in mind, which was to make this usable for everybody. So we use a lot of drag and drop stuff and things like that. We don't have layers and layers of menus on the screen in front of you. Everything is done over a browser. So when you're doing something to make a configuration change using, you're on Google Chrome or something like that, or another browser, that's what you're using to look at the configuration tool of the intercom system. And a panel is represented as a little orange rectangle. And if you want this panel to talk to that panel, then you literally pick up the icon of the one you want to talk to, and you drag it onto the key of the first one, and that key will automatically give you the ability to communicate from panel 1 to panel 2. It's as simple as that. And everything that's in there, whether it's creating party lines, IFBs, groups, whether it's handling logic, or whether it's connecting to the outside world, all those pieces that are in the Infinity system are handled via the same kind of very simplistic icon-based drag and drop technology. And I think we've done a good job. I think we get a lot of really positive feedback about the user interface. I think we've got the right tool.
Well, I've gone through your class, actually Jake Alderman's class at at Telos about using the dashboard as it's called, and I thought, wow, this is pretty easy. It really is just drag and drop, and things just take care of themselves. Martin, I wish we could talk longer, but we've got to go. So we're going to have to say goodbye. Well, I'll tell you what, I'm going to put some links in the show notes about resources. We got a white paper or two about this technology and some demonstration videos that talk about Infinity, about intercom over IP, and I'll put it there. Martin, you have stayed up late at night, and even with the tail end of a cold, I appreciate you staying up and visiting with us on This Week in Radio Tech.
Absolute pleasure, Kirk. Always, anytime.
Well, it's a pleasure to see you, and I hope to see you. Will I see you in February, early February in Cleveland?
I'll be in sunny Cleveland in February. Yeah, wrapped up nice and warm. I'm off to Miami on Monday. You know, I'm going through it. 80 degree. I'll be 80 degrees on Monday in Miami, and then a few weeks later I'll be in Cleveland, and who knows what it'll be.
Oh gosh, I'm so sorry. Well, thanks again for being with us and staying up late there in England. And we'll have to tell the fish stories another time because we are out of time. This Week in Radio Tech.
That big.
Yeah, there you go. Hey, we list our sponsors on every show. Be sure you patronize our sponsors, please. It lets them know that the show is effective for you. We get so many compliments on the show. Be sure you tell our advertisers about that too. It's really helpful to us. Thank you very much. And subscribe to the YouTube channel. Look for This Week in Radio Tech on YouTube and subscribe to it. Also look for Guys from Queens, GFQ Network, where you'll find lots of fine podcasts. I want to thank Suncast, our producer for the show. Great job as usual. And thanks also to Andrew Zarian, the founder of the GFQ Network. I'm Kirk Harnack, and hey, maybe Chris Tobin will be with us next time. He does send his regrets, and we'll see you next week on This Week in Radio Tech. Bye-bye.